Part 2. So this is really helpful because now we're going to look and see how we can figure these kind of problems out. I to the 25th. Okay. So when we have I to the 25th, here are our steps for any of these problems. We're going to take the exponent, and divide by 4. We're going to take the exponent, divide by 4. That's going to help us find the remainder. So let's do these first two steps. We look at this. We have I to the 25th. So I take that out, and I want to divide 25 by 4. This is related to the point that I to the 4th, any multiple of 4, is always equal to 1. So we're going to use that to figure out, okay, well then what are my next values always going to be? When I do so, this is going to be, if I change into our mixed fraction like we had, it's going to be 6 and 1/4. What was my remainder? My remainder was 1. This is the nicest part of working with I. Based on your remainder, every single time, I can conclude that I to the 25th is equal to I to the 1st. You're basically going to take this remainder and you're going to say, my new problem, this makes it like a new problem, is to substitute in that remainder for your value for the exponent. Okay. We'll do a couple of these and it'll start to click. So we know that I to the 25th is equal to I to the 1st, which is root negative 1. Okay. So as a group, let's go ahead and do this one. I want you to try I to the, let's do 11. Go ahead and do I to the 11th as a group. Remember, follow the steps, but also keep in mind that they're always going to repeat. Always going to repeat as the exponent goes up. Same thing.
Awesome. Okay, team. Yeah, it's equal to -5.
I'm positive. All right, so we're back to this problem, I to the 11th.
Oh, yeah.
What are our steps? We know that multiples of 4 always give us 1. So we want to see how far we can get with the multiples of 4 and what's our remainder. So we take the I, we divide it by 4. What does that give us? 2 and
3/4.
4. Good. What's my remainder in this case?
3.
3 is my remainder. So I know my remainder is equal to 3. So what do I know about I to the 11th?
It's negative I.
Good. So you're a step ahead, a step 1 back. I to the 11th is equal to which one of these main 4?
Third.
Doing T's. I to the 3rd.
Okay.
That's going to work every single time because, as I mentioned, if we did these out all the way to 100, these 4 answers would keep on repeating all the way down. Okay, so this is like a trick to get to any number you need to. Okay. So I to the 3rd, we go here and we look. It's equal to negative I, or you could have written negative root negative 1. All right, let me give you one more. We need one more? Can we do this one real quick because we're sped up now? Good. All right. How about? Okay. Let's go with I to the 102nd. Right? That would not be as fun if you were writing them all out. You got to do 102 lines. So you might be at the point, Omar, good. You might be able to see it. Just see it. Because you divide real quick by 4, you get the remainder, boom, you know the answer. Right? So you did it. William.
And there's no remainder, does that mean the answer is 1?
Correct. 26.
Did you get negative?
26. There is a remainder, though. There is a remainder. Okay, 3 more seconds. 2, 1. What are we going to do with this 102? We're going to take it. We're going to divide it by 4. We know that we can, 4 quarters is $1, so I know there's 25, and then what is left over? 2 fourths. This is really, really key. Since we're interested in the remainder, which was 2, right? We do not reduce this fraction. Don't reduce. Remember, you're just looking for the remainders. Remainder is 2. If I were to go in here and reduce this, I would end up with 1 half, and that's going to change the answer. So we're using this just going to mixed fractions just to remember that the remainder is left on top. Okay, so what do we know? I to the 102 is equal to I to the what power? 2. Whatever the remainder is, bring it down, that's 2. I squared is. All right, we're seeing how we're going to get these pretty quick? Okay. Great. All right, we only have, really, these two go together, these two components here. So this is a new section. We're going to go to put, same lesson, just different section. We're going to learn about complex numbers. Complex numbers basically just have one element that's real plus an imaginary element. We just learned what imaginary numbers are. Real numbers, remember, are anything, it's really anything that's not imaginary. So positive, negative numbers, fractions, all those, even irrationals. So a real number out front. This is the form for a complex number, the common form. Plus some coefficient, which is a real number, but it has this imaginary number connected to it, I. So this is our real component, this is our imaginary component. Together, they make a complex number. I want you really quick, identify the real and imaginary components for these two complex numbers. You can just circle the real, square out the imaginary. This should take, we got to write it out, so I'm going to guess 15 seconds. This is really straightforward of just labeling and knowing where, what goes where, what goes where. All right, how about bananas? Bananas for the first one. Somebody help me out. Which is the real and which is the imaginary?
6 is the real number, and 7, I is the imaginary number.
There we go. Pretty straightforward. Okay. Sedmak, do you want to do number 2?
Yeah. Geez, number 2's gonna be a really hard one.
Okay.
Because 10's a real number and 8's an imaginary number. It took me 4 years to figure this out.
Yes, I'm so glad that's on video. Thank you. All right, perfect. Thank you. These are, so you're pointing out these are really simple to identify what's what.
Yeah.
As long as we have the format, you're absolutely right. This is going to be so easy that we can do this really quick. Now, what would happen if my A value was 0? What would happen to this situation? Would I have a real component at all? If A was 0, the real component goes away, right? And then we'd have a wholly imaginary number. Wholly as far as this wholly. Wholly?
Yeah. No. Hope.
Thank you.
Wally.
Wally? Wait, how do you spell Wally?
H-O-L-Y.
No. That's right. Thank you.
That's right.
Got it.
Wait, what?
Okay, great. So all I was pointing out, if A is 0, then you have a wholly imaginary number. There's no real component. If B is 0, what kind of number would we end up with?
Real.
Wholly real.
Holy. Sounds weird.
So within a complex number, if you have that going on, there might be a real straightforward question. I just want to point that out. That's kind of like a footnote. All right. Are we good with this? We all know to spell holy now? Matters for fun? All right, let's take a look at this. This is an application to electrical engineering. With this, and also not just electrical engineering, that's really connected to computer science. Often those two majors are combined. It's called EECS, E-E-C-S. Very hard major. But they're going to use this idea quite a bit. It's talking about impedance, which is the resistance within a material. So some metals conduct electricity much easier and much more effectively, so efficiently. So we can always find out the resistance. You might write that. This is talking about the resistance, okay, of some medium, metal, whatnot. Okay, so this is standard form. This is a complex number. It has a real component, an imaginary component. And the way we're going to input our values, the real component is always our volts. This is our real. Our imaginary number is always in milliamperes. So milliamps, you could say. And I is connected to this imaginary part. It's part of how these values are computed. So if I just have to rewrite, I want you to rewrite as a complex number. What is impedance? If you have volts of 10, milliamps of 3. So again, this might take, years, decades. Yeah. Absolutely will. Okay. Okay, coming back together. I'm going to rewrite this in our complex number form here. And I know my volts, that's the real component. So what do I put in for volts?
10.
10 plus
3.
Milliamps goes as part of the imaginary number connected to I, so we end up with 3I. 10 plus 3I. Bless you, bless you. We got that? Is that really straightforward?
Yeah.
Now, it can get more complicated. When you get to physics, you might actually, when you get into waves, you might be working this out without these two things given. So just know that there's trickier, but we won't have to deal with it in this class. All right, we're in good shape. Let's go ahead and get to the classwork then.